Geotrig, this is lesson 6 outline. This is the first day. We're going to talk about fractional equations. Fractional equations, guys, I have there the LCD with exclamation points like crazy because the LCD is your friend. And remember, what is the LCD?
Least common denominator.
Least common denominator. Thank you, Paige.
You're welcome.
So,
I can't see what I'm writing.
So we're going to find the LCD. Now the LCD, guys, I'll put some steps on the side over here. So the LCD has steps. Number 1, and we've talked about these. I think this is a good time to possibly write them down. And number 1 is factor all denominators. Factor all the denominators. Notice that we actually have 3 fractions on this problem here. And if you look at that problem, the first denominator is a 7, the next one is x plus 2, and the last one is a 3. They're already all factored for us. So in this case, it's not too bad. And as we start off our problems in our book, they're going to start off a little bit easier. As we get more and more exposed to it, they start to add more things that you're going to have to factor by pulling an x off or having multiple parts to it. Number two is write down first denominator. You write down the first denominator. So for our problem, we got LCD. We already established that they are factored. So I write down the first one. The first one is a 7. So I'm going to write that down. 3. Step 3 says, looking at the next denominator, ask yourself, is it there? And if it's not, multiply in what's missing. So I'm going to put multiply in what is missing from others. So, what does it mean? I look at x plus 2. Is x plus 2 a 7? No. So therefore, when I go to my LCD, I have to do x plus 2 there. I am multiplying it in. It's not there, so I multiply it in. And then I look at 3, which is the next denominator. Is 3 a 7 or an x plus 2? No. So I have to multiply it in. Now we have this LCD. I could multiply the 7 and 3 together, and I think most of us would understand that would be 21x plus 2, right? Just makes it a little bit smaller. Notice what I didn't do, though, was distribute that 21. I think putting numbers together, that's fine because I know the factors of 21 are 7 and 3. It makes it a lot easier to deal with. Now, what am I going to do with this LCD? I'm going to work some magic here, and I'm actually going to be able to get rid of the denominators of that whole entire fraction. Or equation, sorry. Because this is an equation, you have an equal sign. This does not work with expressions. It only works with equations. And that whole idea of the rule is what you do to one side,
You do the other.
you do to the other. And so therefore, it's legal move. And that legal move that we're going to do here is multiply both sides by the LCD. I know it's kind of squishing it in right now. So now, we're multiplying to both sides. And now, what happens is that on the right-hand side, we can see directly that 21 and 3 will interact with each other, because 21 divided by 3 makes a 7. Can you see that? I know it's a little bit smaller. So I end up having, on the right-hand side, 5 times 7 times x plus 2 left over. Can you see that? The 3 on the bottom will cancel with the 21 to make the 7. Going to the left side, I'm going to take that LCD and distribute it in. Essentially, I'm multiplying the LCD to every term, just like we did to our complex fractions. And so what happens here is the 7 and the 21 cancel to make a 3. And then I end up with 3 times x plus 2 times, not 7, but 4. That's only the thing that's left. Plus, what cancels on this one? The x plus 2's. So I'm left with a 21 times 3. And now I can start to clean this up. The 3 times the 4 make a 12. Taking it one step at a time. 21 times 3 is 63. 5 times 7 is 35. Now, I think most of us would agree that I have to get x by itself, right? Because I got to solve for x. Now, I think almost all of us are instinctively saying, I'm going to take the 12, distribute it in, take the 35, distribute it in, right? But wait a minute. If you think of it as groups, I have 12 of x plus 2's. And on the other side, I have 35 of the x plus 2's. Could I move the whole entire group together? As in, could I actually subtract 12 times x plus 2 from both sides? Is that a legal move? If I have 35 of them and I subtract 12 of them, how many do I have? 23. 23 of what?
X plus 2.
X plus 2's. It's easier if I do it that way than if I distribute. If I would have distributed, that would have been fine. I would have came out with the same answer in the long run. Just like you have an option now. Do I distribute, or do I realize that the 23 is hanging out there, that I can just divide it out from both sides? Doesn't seem like this is going to turn out to be a very nice number. I'm going to divide both sides by 23. This is gone. So I get 63 over 23 equals x plus 2. Uh-oh. Can I reduce 63 over 23? No. I don't think I can. It's 23, I think, might be a prime number, right? But that means I got to subtract 2 from both sides. But unfortunately, that's a fraction, that's a whole number. That means I need to actually switch it to
improper fraction.
an improper fraction, or what's the equivalent of negative 2 with a 23 in the bottom. I have to do 23 over 23, right? I'm multiplying negative 2, which is really negative 2 over 1, times 23 over 23. And what's 2 times 23?
Negative 46.
So negative 46 over 23. What do I get when I put those two together then? They have common denominators, so it's going to keep that denominator, correct? You guys agree with me on this?
Yeah.
So we can say x is going to equal something over 23. And what's 63 minus 46? We know it's got to be less than 20. It's going to be positive because 46 is less than 63. 17. So your answer is 17/23. next problem with fractional equations has a fractional equation there. 3/7 x plus 2/5 y equals 11. But then we also have 0.03 or 3/100 x minus 2/10 y equals a negative 37/100. I don't like to deal with necessarily fractions, and I don't like dealing with decimals. There's actual ways to make it so there's no more fractions and no more decimals in my problem. So therefore, I can use or work the system with linear combination or substitution. That's what we have here. We have a system of equations this time. But to get to our systems of equations, to make it easier to work with, I'm going to switch those into nice numbers. By number 1, on the top one, multiplying both sides by the LCD. The second one, I'm going to move the decimal place. Let's start with moving the decimal places. How do I move decimal places? By multiplying and dividing by 10. I have to move the decimal place how many spaces at the very least to make all three numbers nice? Or whole numbers? 2. So that means I'm actually going to multiply the whole entire equation by 100. Boom. So I'm going to multiply that equation by 100. And when I do that, it moves the decimal place 2 over, so I get 3x. 2 over, so I actually get minus 20y. And move it 2 over to get a negative 37. Is everybody okay with that? You've actually moved decimals before by multiplying and dividing by 10. The top equation. Are the denominators factored? What's underneath the 11? It's really a 1. Okay? So we got a 7, 5, and 1. If I was to really find the LCD using the method we talked about, since they're already factored, I'm going to write 7 down. I go to 5. Is 5 there? Is 5 part of 7? No. So I need to multiply that in. 1, don't care about. 1's already there. 1 technically is. So actually the LCD is 35. Now, going off of what we just did in the last problem, I multiplied both sides by 35, right? Then I said, wait a minute, on the left-hand side, and even on this one, I had to distribute that 35 in. Essentially, multiplying to every term. So this is what I'm going to do. I'm going to multiply every term by 35. The nice thing about this is that every one has a 35 next to it that allows me to cancel with it something on the bottom. Like the 7 and the 35 make a 5. The 35 and 5 make a... And the 35 times, it doesn't cancel anything. So what is that equation? 5 times 3x is 15x. 7 times the 2 that's left over is 14y. And then what's 35 times 11? 35 times 10 is 350, plus another 35 is 385. We've now just created a system of equations that we should be able to solve using, I think, linear combination. I think that'd be easier than just do substitution because there is no variable by itself right now. What would be the easiest thing to do to solve this? Multiply the top by negative 5 because we want our numbers to be the same but opposites. So when I do this, make sure you distribute all the way through, and so you get negative 15x. You get negative 5 times negative 20, positive 100x, or y. And all the way across, a negative negative makes a positive, and what's 5 times 37? What do we get? 185. Sounds about right. We by engineering it this way, the x's will cancel. And what's 14 plus 100? 114. And what's 385 plus 185? That's a 0. Carry the 1. That's 16 plus 1, which is 17. Carry the 1. 570. And my final step to solve for y is
Divide by 114.
divide by 114. And we find out y is equal to 5. A nice number. That's nice. Now, we know what y is. Now we have to plug it back in to solve for x. Which equation do you want to put it into? Do you want to put it into the 3/7 x plus 2/5? Or how about the 0.03x?
The bottom one.
Or can I put it in 3x minus 20 equals negative 37?
That one.
I'd rather put it in that one. 3x minus 20 times 5 equals negative 37. Yes?
Yeah.
What's 5 times 20?
Negative 100.
So it's a minus 100 equals negative 37. I think we agree that we should add 100.
Let's see.
And 3x will have to equal positive 63. And then if I divide both sides by 3x is equal to 21. The final answer, though, is I got x, I got y. We're talking about a system. A solution to the system is a coordinate or a point. And that coordinate or point would be 21, 5. How do I know if I got that right? You can plug it back in. You could plug it back into the original two, and it will work in both.